Thank you. Good morning. So I opened the conference for you guys a couple days ago with Glenn. Here we are closing it. And before I get started, why don't we all give a round of applause for the Engage team, Phil, Paul, Lisa, Spencer, and everybody. I hope everybody learned a lot over the last few days, and I hope you're going to learn a lot from what I've talked about today. So a little bit more about me. I'm going to sort of interweave some stories into how to think about AI in the enterprise. I got my start in artificial intelligence at the University of Arizona. I became a CTO in startups that were processing classified ads from thousands of newspapers and trying to make them searchable. I then went on to become a CIO at 3 different companies that were processing data to build analytics and customer-facing applications. And along the way, I wrote this thing called Driving Digital. I'll talk a little bit more about that at the end of this, but it's really about all of you being successful with digital transformation, how to run your organizations like technology organizations, how to put programs like Agile and DevOps and becoming data-driven into your organization. Of all those things, and of all the emerging technologies that people are telling you to pay attention about, the one that I think is most important, most viable to many of your businesses is artificial intelligence. I was glad to see Ken and Ashish talk about that yesterday as not hype, as something that's reality. But in there's a huge spectrum, okay? And what you're reading about that the Googles and the Facebooks are able to do with mounds and mounds of data, with tons of technology and really good talent may not be accessible to the average enterprise. And so what we're going to talk about today is, well, how do you get involved with it if you know it's the next big thing? So first, let me convince you some of the things that are going on out there and why I think being slow to adopt some of these things early on and to get onto the train of learning how to use data to do machine learning experiments is really important. So first is this statement, companies slow to adopt AI-based productivity improvements, be warned. It's the biggest commercial opportunity for companies, industries, and nations all over. So that sounds like a lot of hype. But the group that put this out also shared some numbers around this, and they think in the near term, it's going to drive $6.6 trillion in productivity improvements. Okay, so those are things like RPAs. I think somebody talked about RPAs yesterday. Things that are going to take manual processes and not necessarily make them totally artificial, but augment the intelligence of the group of people that are operating this. So you're going to see this slowly emerge in many organizations that still have a lot of manual process, that might have some BPO with a lot of people doing basic common repeated tasks. It could be chatbots that are repeating, responding to lots of the same questions over and over again. But what really excites me is that target for 2030, where we start seeing AI being applied to grow our businesses and providing customer experiences and differentiating factors, and bring that total up to $15.7 trillion of potential delivery from AI-based investments. So think about that. 2020, we were talking about, is not too far. I have to tell you, when it comes to AI, 2030 means you need to start thinking about some of these things now, because your data isn't ready, your processing isn't ready, your internal processes and how you think about things isn't ready for it. The example on the right side is just one of the many examples of where you can get AI embedded into the technology that you're buying today. So, you might hear a lot about going out and experimenting and putting machine learning in your organization, but one of the easiest ways to start is looking at your vendors and saying, what are they putting into their technology that has machine learning capabilities where I can see an impact? This particular technology is leveraging the video cameras that are up at every job site, and they're looking for safety issues. Okay, so it's not just, is this person the right person to be coming onto the job site? We saw Vantic do an example yesterday at the case studies around facial recognition. This is going one step further, right? This is saying, not only is it the right person, but are they doing the type of work in a safe way that is going to make sure that we aren't taking more risk than we should be taking on? So looking for context and making decisions over it and flagging it and providing analytics back to the organization in terms of what people are doing. So lots of opportunity there. This is one of the examples from my history. I built this back in 1997. This was parsing through, I think, about 2,000 newspapers worth of classified ads, looking for things like the number of bedrooms in a real estate ad or the type of cars, the types of jobs that were out for market, and putting a search engine behind this. This is an example of natural language processing. It's one of the more mature areas in artificial intelligence, but it's also very contextual, right? There isn't a black box approach to just applying natural language to the different types of content that you have in the enterprise. Some of it is very specific, like looking through a paragraph of information for dates and people, and some of it is more broad at looking at an entire set of legal documents and looking for when contracts start and end and for certain terms in the policies in your contracts. So lots of different examples of natural language processing and search in particular. Very contextual, but a lot of different solutions out there that you can get on board today to make people's time more efficient, to find the most relevant information that is being looked for, to actually get analytics out of some of the content that you have, and then look for new ways to deliver efficiency to your organization. So how do I look at a particular opportunity? How do you look at a particular opportunity to decide, is this something that we should put focus on? And so I'm not going to start with the technology, and I'm not going to start with the data. I'm going to start with the answer in mind. If I start working on something and I arrive at an answer and I find that it's achievable, what is that worth to this organization? What kind of value can I get from customers if I do these things? Can I build a new product? Can I improve efficiency around it? That's how I describe the business opportunity. And I describe it in a way that says, we can get this done. Now let's go back and look at how we monetize this, or how do we derive an efficiency around it. I then go into some of the things that enable that capability. And I start with the data. Do you have the actual data that can support the hypothesis that you're going after? And what you're going to find most likely are two things. You might have the data, it might be inaccessible, it might not be tagged properly, it might have some data quality issues, it might not be in the right storage mechanisms to manage it, some of it might be outdated and you have to refresh it. So all the things that can go wrong with data that you're already dealing with your analytics programs and data science programs are going to be magnified when it comes to AI. Here's another one for you. Okay? The other one for you is bias. Okay? If you're going to go train an AI and have it provide a general solution for you, is your data are you giving it a training set that has inherent biases into it? All right? And so that's a skill set that you have to put into a program around AI that's going to look at and say, do I have a statistical significance against the population that I'm providing the AI to learn from? All right, and if you don't, you're going to have to go out and look for data sets to complement what you have. This is why for most organizations, AI is going to be a long investment to be able to have the right corpus of data around it. Then you got to start also looking at AI capabilities, and what that means is you're going to read a lot about deep learning, and deep learning is showing a lot of promise, but it's not the only artificial intelligence that's out there. You can find AI built into technologies. If it's a content problem, you're going to look at natural language processing and generation. If it's a problem where you don't have a training set or it's a real-time problem, you're probably going to look at reinforcement learning algorithms. So this is where you need to start thinking about partnering. If you don't have the expertise in-house to actually help discern what types of algorithms and technologies to program those algorithms, look at some experts to help you with that. And look at trying to set up some POCs that will allow you to go and experiment with some of these different algorithms. The last bit of this is the agile culture, and the reason I put this in here is you can think of AI as sort of the intersection of data and analytics with application, right? And we already know applications need to go through an agile program to be able to iterate and use feedback to get better. We already know that that's happening in a data science program. It's magnified in an AI program. because the initial algorithms that you're putting out there may not be the optimal ones. Even if they are, you have to tune that algorithm. You got to look at the topology of a deep learning network. You got to look at your training sets and see if they're viable. And if you have executives asking you questions like, when are you going to have this done, and are you going to have it done in 4 weeks, that's really going to be very hard to use in a culture. It's a really hard thing to surmount in a culture when you're trying to actually have to experiment with a lot of new technology and data. Okay, so when we talk about 2030, these are some of the building blocks that you have to get to, particularly in enterprises that are more conservative. What types of opportunities? If you don't think there's opportunities in your organization to actually leverage AI, look at this chart. It's in every single one of your departments. In sales, okay, how many of you have salespeople who have to prioritize their leads? Look at a CRM program and say, what part of my day should I participate going after certain programs? How many of you have digital marketing groups? Okay, we talked a lot about events yesterday. Digital marketing groups understand events. They're looking for signals that suggest that somebody is about to go buy a car or maybe move and sell their house. Okay, so 2 examples that you might not be able to think about for AI, but they're looking at behavioral signals that say this person might be shifting their mindset and be ready to hear my message. In customer support, think about chatbots. Okay, things that can take lots of activity being funneled to a large number of people and reduce that down to a handful of more complex issues. And in finance, think about RPAs, a lot of data entry and legacy systems that can be operationalized by using AI-type technologies. It's happening in operations and IT as well. All right, so how many of you have AI built into your incident response systems? Looking at things that can go wrong in your applications and tell you, I think it's the web service that broke, and that's the one that you should go look at. Okay, why do we need this? It's because our businesses expect higher levels of service, and the number of data points and information points to understand how these applications are performing are becoming more complicated. Same thing happening in security, right? We've been protecting our perimeter. We know that's not good enough. How are you going to look at the signals of people inside and outside of your network and saying they are doing things that aren't being done in a secure way, and there isn't some kind of outside agent doing something on my network? Machine learning could be applied to the types of actions different people are doing in your network and look at for things that are anomalies for that particular group. So lots of very nuts and bolts. I didn't even get into anything that's innovative or something that's specific to an industry. These are nuts and bolts things that you can go look at inside your organization for places to apply AI and get benefits from. How to think about the actual problem, okay? I think about it in a number of different contexts, okay? And contexts include who the person is, where are they, what time, what is their issue, but most importantly, why are they trying to solve a particular problem? These are the kind of contexts that you really want to feed into an AI program. I think about where they're going to consume the information. So are they in a classroom where they have a particular question about their next class and they can ask Alexa a piece of information around that? Or is it on their wearable? So what is the context? What's the medium by which somebody's going to consume the information that they're providing you? And then what's your data sources that are available to you to actually feed into these algorithms and be used to provide context around the answers around it? So lots of input information, lots of things to consider when trying to answer questions that have AI built into them, and lots of different delivery contexts are what driving different ways to program artificial intelligence. And this goes into your implementation, right? The art of starting an AI program is figuring out which data sources are most relevant, which delivery mechanisms are most relevant, who your personas are, what types of problems you're solving for them, where do they get value out of that, and bring down that problem into a manageable subset. Because if you try to throw everything at an AI up front and try to make it available in all contexts, you're going to be giving yourself too much work to do up front and probably are not going to see early results. right? So figuring out how to skinny down the problem to an MVP that you can actually start seeing some value from. This is one of the examples that I'm working with. How many of you know who Charity Navigator is? Got one person here. My New Yorker over here, that's cool. Charity Navigator is a company, they're a nonprofit that actually looks at the behaviors of other charities and rates them on two dimensions. How they do how they perform financially, they get that off of their tax forms that are public information, and they get it through something called accountability and transparency. These are looking at essentially the governance of the organization. Do they publish who their staff is, who their CEO is? Do they publish the compensation of the CEO? Do they have a privacy policy out there? Do they have a whistleblower policy? So all the different things a corporate governance should have are things that they can look at in a nonprofit. One of the problems that we had that we were applying natural language to is how do you determine what cause and what type of charity this particular charity is? And when you're working with 9,000 charities that they're working with today, we can put a person on it and they can go look at the charity's mission and its title and discern that it's an animal charity. When you're working with 90,000 charities, which is their goal to grow their ratings to 90,000, applying people to look at charities and discern a cause is a little bit manual intensive. They're a charity, they're looking for technologies to do this, and we're applying very basic natural language technologies to go out and come back and say, we think this is one of the 37 causes that they measure. So examples of things that can take very simple bits of information, take some heuristics, put it into an algorithm, and come back with answers, and take out people in the process and apply those people to do more important things for growing their ratings. So this is one of the examples that I'm working on. Let's take a more advanced example. Okay, let's talk about what happens when I have all those IoT sensors and mobile devices out there. I have all this information feeding in. What am I going to do with these things? And there's two things I think people have to think about. Why is IoT and AI so important? The first thing is you need to make decisions and take actions at different levels. So if you think of a self-driving car, that car has to know to put the brakes on because the car 3 cars ahead of it has already applied the brakes. I'm going to make a decision right in that car to apply that. I'm going to have a more local decision about how to control the traffic lights in the local area of all the cars so that I can make traffic flow in this immediate area. And then I'm going to have a more macro view, right? How is traffic flowing through the system? There's a football game going on. How do I need to address traffic patterns to allow people to exit the stadium efficiently? Right, so decisions being made on the events at multiple different levels, different types of data required at different places to be able to do those decisions. You might be looking at very low-level raw data at the edge when it's making a decision on whether to brake, and you might be looking at aggregated information up at the central area to make more macro decisions. So this is the most interesting things about AI and IoT. The technologies that are out there on the AI stuff are starting to process data in streams. So look at not just a batch process, but look at how data is coming in. Am I going to look at a 60-second window or a 6-minute window worth of data? How do I store this data so I can process it in real time? How do I apply AI into a window of information? So maybe apply AI to 6 minutes worth of traffic data and make some new decisions around it. And these are the types of technologies that if you are building things up on your own, you're going to be looking at things like Kafka and Apache Spark Streaming to be able to process this type of data. Okay, so obviously we're getting into the harder problems inside artificial intelligence and looking at streaming data, looking at some advanced technologies around it, looking at marrying IoT data into it. But this is where things are going, right? And so we need to prepare our organizations to be able to do that. This is one of the practices that I talk about in the book around becoming data-driven. This is essentially about cataloging your data sets, again, looking at the data sets that potentially provide the most value. doing some experimentation around it to make sure you have the right data quality, that it can actually answer questions and allow you to discover new things about the particular problem that you're doing, and then to rank the results, right? Should I go back and work on this data set again, or even this problem again, or is a new question come up that should take a higher priority for my data scientists and machine learning expertise? That's the agile process I just described. It's being applied into data and analytics instead of software development where we traditionally think of it. But because it's a science, right? We're looking at the output of data and analytics. The question is it actually going to provide value? To me, this is all about changing our organizations. Our organizations need to be smarter. They need to be faster. They need to be more innovative. That's what I think digital transformation is all about. This is not a straight path to the answer. There are practices that are involved with it, from agile DevOps, working with product development to build customer-facing technologies, and really applying data science. This is what I do for a living, and I'm really excited to come and talk to you guys when you do your one-on-ones later. A little bit more about what's in the book. These are the different subject areas that I cover inside the book. I have a couple of copies that I will have at my desk if you want to go page flip through them, or if you just want to come up and ask me a question about them. So I hope you enjoyed AI and learned something from it, and if I have a minute, I'll take a question.
Yes.
Sunil Chandrasekharan, FIS. My question is around, what are your thoughts about general AI? I mean, we're talking about more on the applied AI here. What do you think about, general AI? Is that going to be the next thing, or are we there yet?
I do think it's going to be the next thing. Okay, I think you have to think of it as a new way of programming technology, where it's not rules-driven, it's not procedural-driven, it's data-driven, it's using analytics inside the machine to actually come up with outcomes for you. So it's a different way of thinking about how to process data, right? So when people come to me with heuristics, right, if A, then B, no longer really applies when you're dealing with hundreds of dimensions with data from multiple sources flowing through your systems on a daily basis, right? So that's the paradigm shift that I see happening. I don't believe in some of the hype around some of the cognitive capabilities, right? And when I talk about it, I'm not talking about truly artificial intelligence where all the trucking in the country is going to be replaced by autonomous drivers in the next 2 years. I think that's a 10-year horizon. I don't think it's going to be completely automated either. We saw a picture earlier about what Tesla's manufacturing plants look like. All right, so I think you're going to continually see how machines can process more information, provide more results, augment the intelligence of the people on the staff. It's going to require people to think differently. They're going to operate at a much higher intelligent level. They're not just going to be, putting a bolt onto a system like they used to, because the robot can do that. But I think as we get more accustomed to throwing our data into these systems, we're going to find ways to actually have differentiating value. So I think it's real. I just think you got to start small. Whoa. Didn't see that one. Get too excited on that.
Easy.
I told you I need the espresso. Yeah, there's none of that yellow stuff there.
Hey, Isaac.
Hey.
This is Harvey Guindy from H&L. One of the challenges I'm having is educating my executive team as well as my general population about all the factors of AI, the difference between AI, machine learning, deep learning, cognitive, and all that. And so one of the questions I get is, because one of the things I'm trying to do strategically for the business is build predictive models in healthcare, and specifically around lab diagnostic data, like predicting sepsis, predicting diabetic progression. What's a good source? How would I begin even educating? Because one of the things I get is that, I just saw that Salesforce has Einstein. Make Einstein do it. Or why don't we just buy IBM Watson? That'll just do it. Why are you building all this?
Right. I think you have to use analogies that your business people understand, right? So, you're doing clinical trials. They're not 2-week exercises, right? They take time to actually put the right experiments in place, to do the right analysis in place. It takes a bunch of time to be able to get something done outside of the IT and the technology and the data and the AI, right? And so when you're explaining AI to executives who are just reading through the hype and think they can buy off the shelf and get it plugged in, you have to remind them in context that they understand that you're just buying a tool, right? You haven't actually operated it. You haven't figured out how to make it work. You haven't figured out what problems to throw it at. Even when you bring in their experts, they're going to have to understand the data quality that you have. They're going to have to understand how to apply your data into the machine learning algorithms, and they're going to have to iterate over the topology and the, sort of the manufacturing of that system to be able to get answers out of it. So try to put that kind of answer in the context of things that they understand, and then come back to them and say, we're going to start by doing a series of very small experiments. Right? And then go back to your experts and say, what's the POC that I can apply to here to actually show some results, and also set the right level of expectations over what we can accomplish in the short term.
Any other questions for Isaac? Isaac,
All
thank
right.
you so very
Thank
much.
you.
And